All right, so today what we're going to do, we've been talking about binomial distributions, right? And we've learned how to read them from the chart once you're given all the information you need, yeah? Well, today what we're going to do is we're going to look at what happens when you have to work backward. And if you think back to the Poisson distributions that we did, when you worked backward, we were only able to do that in one case. And that is when our x was 0. In other words, you can't work backwards unless you're looking for the probability of none. Otherwise, the computations are just too complicated and it's not going to work. So, again, you get lucky there. Because what happens is, when you get all those zeros and plug them into the formula, remember that when you make something equal to 0, or you have when you have an exponent of 0, it turns it into a 1. If you have something, and if you do something factorial, it turns it into a 1. So what happens is most of the formula goes away, which is good because those formulas are a nightmare. So I'm going to give you the simplified version of the formula, and then we're just going to use solver to be able to solve the equations. Okay? Now, that does mean, however, you must memorize the formula, just like the other formula that we had to memorize. And you have to remember that it's not the same formula as you had for the Poisson distributions. Okay? So you've got to remember when to use it and what it is. Yeah? And remember, these are not going to be on your formula sheets. On your formula sheets, they give you the long, drawn-out thing. So be careful. All right, now, so what we're going to do is, I just want to talk about the things that you need. You remember for binomial distribution, just the straight binomial distributions, we needed a couple of pieces of information. We needed our n, which is the number of trials or things you're doing, right? We needed our probability. And remember, that's the probability of success that we were dealing with. And then finally, we had whatever our x was. And that was some given value. They always gave us the value. So what's going to happen this time is that we're going to be looking for working the other way around. We're not going to know this part in most cases. If we do know that part, then we're not going to know this part. Now, the x part's easy because for all inverses, it's always going to be x equals 0. So that's easy. But for the rest of it, we're going to have to find the pieces. So for inverse, we need to remember that we're going to have some unknowns. So we're going to have an equation to solve. And the equation we're going to solve, we still have n is the number of trials. That doesn't change. We have p is the probability of success. But for inverse, we're always going to be looking for where x equals 0. So we need the probability that at x equals 0, and that simply can be translated as the probability of not success. Okay? Does that make sense? And we know how to find the probability of not success. The probability of not success is simply 1 minus the probability of successes. Yeah? But because of the formula, it's going to have one little addition in there that you're not going to, that again, you just have to memorize. So here's the formula that you're going to use. And again, your calculator can do the math for you, but you have to memorize the formula. The probability that x equals 0 can be found by taking 1 minus the p, and p is the probability of success, remember? Okay? And raising it to the n, where n is the number of trials. And again, Sometimes you're going to know the probabilities. Sometimes you're going to know the number. You have to be flexible about what you're going to do, what you do and what you don't know. Okay? Make sense? All right? So what happened is, if x is 0, what happens is it just made a bunch of the formula just drop away. So if you want to see it with the whole formula so that you can then make that leap, just in case you forget, I can show that to you if you want me to. All right? And perhaps it's a good idea, just so that you know that, because that formula will be given to you, but when you're doing and the only time you'll use it is for the inverse, which is when x is 0, and so a lot of things will drop away. So let me just show you that really quickly, and it might make your life easier, because then you won't have to memorize it. You'll just have to remember what happens to it. Okay? At the top of the page, you're going to see probability of x equals some x, some capital X equals some lowercase x, is equal to n of the x, probability, remember the pi stands for probability, so you can just as easily replace that with p. Probability of x times 1 minus the probability raised to the n minus x. So, if we're looking for these, our x has to be 0. That's the only time you can do an inverse, yes? So what's going to happen? Probability that x equals 0. We're going to do n things 0 at a time. Pi raised to the 0 power. 1 minus pi, where again, this pi is not the geometry pi, this is just the p, times n minus 0. So do you notice all I did was replace all the x's with 0. And what's going to happen is that becomes a 1. And if it's a 1 and I'm multiplying with it, do I need it? Nope. That becomes a 1. And if it's a 1, I don't need it. So I get 1 minus pi, that stays. And n minus 0 is just what? N. So there's the way you're going to use the formula. So if you you really don't have to even memorize it. What you have to memorize is that when you put in zeros, what's going to happen? All this and all of this and this piece here are going to just go away, and that gives you the formula that I just gave you. All right? So you can derive it from this. So you can practice that a few times, knowing which pieces are going to go away. Anytime you have an exponent of 0, it's going to turn it into a 1, right? And this is something called a combination. And if that bottom number is a 0, if the x becomes 0, that turns it into a 1. Because there's only one possible way that you can get a 0. Okay? So just to remind you, and you can practice doing that a few times, just so that that way you won't have to memorize the formula cold. You can just memorize how it goes from one thing to the other. Because they're going to give you that formula, the ugly one. You just have to know how to simplify it to get it to this. Or you can memorize it. Pick one. Whatever is easiest for you. Okay? So what we're going to do is look at a few questions here using this inverse binomial distribution so that you can use it. Now, again, you're going to use solver on your equation solver and your calculator to finish them off. So after you get the things in here that you need, you don't have to do the math, right? But they're going to want to see this, that you put the numbers in if you're going to use your calculator. You're supposed to, if you use your calculator to do the work, then you're supposed to put in all the numbers first, right? Just to show that you're having understanding. So here we go. Let's just go to the book. Okay, so what we're going to do is just plug in again, put those values into the formula to find out what's missing. So let's just run through that one more time. This side is our probability that x equals 0, and we just calculated that number. We know that number, right? By subtracting the probability that we had from 1. Okay. Then 1 minus p, and we have an n, so that means we put a number there. So you'll know where to put things based on what you have. If you know the probability of it, that it's 0, then you can put that number in. If you know n, then you can put that number in. If you don't know n, then you're going to be given the p, the probability of success, so you put that number in. So here we go. So that's all I've done here is just put the right numbers in the right spot. Now, what they did was they are solving this algebraically using roots. You don't have to. You can enter every bit of that into Solver. And that's what I'm going to have you do right now. All right, so.
Wait, I pressed F3, right?
Yes. So first, so on your calculator, first you do menu. Then you're going to choose SOLV, which is the F3, right? And at menu, the menu number you're going to push is 8 to get to the right menu for equations. Then F3 gets you to solver. And then you're just going to see the thing that says equation. And that's where you're going to type in your equation. Now, the only thing that you need to remember is you need to type it in exactly as it's written here. So you would type in for this particular one. Let me get rid of some of this mess up here. You would type in 8510. So type that in there. Then you need the equal symbol. The equal symbol is not your execute. There is an equal symbol on your calculator. You have to do shift to get to it. All right. So to get to the equal symbol, you'll do shift dot, right? Okay. Then notice our equation has brackets in it. You have to put brackets around yours also because you're going to have an exponent. So put bracket 1 minus p. Now, you can use the letter P. You have letters. They're above the numbers. Or you can just hit that X key and use X. It doesn't have to be called P. X has a key for it. That's a lot easier than looking through and doing Shift P. But if you want to do Shift P, I don't care, right? But put in the variable, okay? Then close your bracket, and now we need to put on an exponent. Okay, well, hold on. Now we have to do an exponent. And remember, to do an exponent on a bracket, if it's not something other than squared, what you'll do is you'll use that caret, that little house key. There's a little up pointing arrow thing looking thing. It's called a caret. Hold on. And then you'll do 10. Hold on. Okay, so to raise all of that bracket to a power, you'll just put the caret and then the 10. And then you generally, guys, have to hit execute twice. For some reason, it gives you some other information first, but then it won't give you the answer until you hit it twice. I don't know why.
No, it's just error. Yeah, it's just error.
Okay. So once they got their number of 0.016, blah, 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 they changed it to a percent because your original started out with a percent. To do that, remember, you just move the decimal 2 places over. And that gives you 1.6% rounded, so approximately, okay, or about. Now, or you could have just taken your value and times 100. That would do the same thing, right? Because remember, to change it to a percent, you just multiply times 100. Okay, let's look at another one real quickly, since that one was so easy. Again. The biggest thing is make sure, ladies, remember, the biggest thing is to make sure you list what it is you know so you'll know which one is the thing you're missing. The company would like to reduce the number of packets of flash drives returned to less than 10%. Given that they use the same flash drives, of which 1.6% are faulty, calculate the maximum number they can put into each packet. So this time we're looking for the number, right? So that means we're looking for our n, right? Okay, so we need the probability of success. So this is the probability, so our p. All right, and then we're going to find the probability. Guys, shh. Then we're going to find the other probability. So we know that the probability we just got from that other question is 0.001. So to find the probability for x equals 0, remember that's always the same. So if the probability we have, our p, is this, then to find our p of x equals 0, we just need to subtract that from what number always never changes? 1. Okay? So when we do that, we get this value. Okay. Now, guys, shh, follow along. Don't worry about the rest of the stuff they've done here. Now, we're going to put that into our formula. Oh, well, we are going to need that, aren't we? So we're going to put that into our formula. All right, this one's slightly different. Hold on. So think about your formula. It's the probability that x equals 0 is equal to 1 minus the probability of success raised to the n power, right? We don't know n, so it's just going to stay n. So I need to find this number, okay? And that's just 1 minus the probability, okay? 1 minus, what was our probability that we just found? Right? And then the probability that x equals 0 for our new number, if they want to do it less than 10%, then that means they want everything else to be good, yeah? So that's 1 minus 10%, which is 1 minus 0.1. In other words, 0.9. Okay? They went ahead up here and did that subtraction for you because if you look in your brackets, they're both numbers. I don't care. Enter the whole thing in there. You don't have to simplify it first. Just enter it into Solver. So just put 0.9 equals 1 minus 0.016. And remember, n is too hard, so just put caret x. It'll give you your answer. Instead of saying n equals, it'll give you your answer as x equals, but that's fine. Okay? It'll say x equals some number. So do it. Let's make sure